Good morning, good afternoon, good evening, good middle of the night if that's when you're reviewing this. I hope not. I really hope you're sleeping. So you're ready and refreshed for the next day. Okay, but today what we're going to work on is adding, subtracting, and multiplying polynomials. And we're still in Unit 7, which is polynomial functions. So today you're going to review how to add, subtract, and multiply polynomials. So we're going to have a lesson, and there is some practice homework that I'd like you to do. Now, before we begin, there is a few things to review. So, combining like terms. This lesson's backbone is remembering how to combine like terms. So during week 1, we talked about what terms were. And instead of week 1, the first unit, or the first lesson of this unit, that's what we were talking about. Now, multiplying. We're going to take the imaginary number, okay? And whenever we have the imaginary number, that's just equals the square root of -1. But if we have I squared, that's -1, okay? Because it's the square root of -1 squared, the radical simplifies out, and we're left with just -1, our radicand. So today's lesson, to add or subtract polynomials, add or subtract coefficients of like terms. You can use vertical or the horizontal format, and I'm going to show you both. It's your choice after that. Okay, so here's our first problem, which is all review for you guys. So when you're adding this in a vertical format, remember vertical is up and down. Okay, we're going to go ahead and take a look, and I'm going to line up my coefficients, or I'm going to line up the exponents. So notice how we're adding this to that. So when we do add that, we are x to the third plus x to the third. Then we also have plus 6x squared and plus 11. Notice how I left some space because I didn't have an x value over here. So it'd really be kind of like plus 0x, but be careful. Make sure you combine like terms. Okay, so we're going to add everything together. 1 plus 1 is going to give us 2x to the third, -5 plus 6 plus x squared. That just stays the same. Okay, and then 9 minus 11 is just 2. So our constant on this equation is 2. Woohoo! We are done. That's all it asked us to do. So let's go ahead and take a look at the horizontal format. Okay, now the horizontal format, that's kind of what we typically do when we have an equation. We would just have y cubed minus y to the squared minus xy. I'm just copying this down. We're adding these two together. Typically you would see this if we were adding it like within parentheses, but there's nothing to simplify on the outside of parentheses, so we do not really need the parentheses. I forgot that this eraser is super wide. Here we go. Okay, so nothing's being squared, nothing's being multiplied. We can jump straight to combining like terms on this problem. So I have no other terms that are cubic, so I can bring down that y to the third. And remember, standard form always has the larger exponent out in front. And then if you had multiple variables, you would go ahead and make sure you have it in alphabetical order. So we do have squared here and squared here, so we're going to end up with -2 plus 4, which is just plus 2y squared. And then our next one is -7y plus 2y. So -7 plus 2 would be -5y. And then our last one is our constant that stays on the end. So we would end up with y to the third plus 2y squared minus 5y minus 5. Okay, let's go ahead and take a look at some complex numbers. So if we're doing that in either format, either vertical or horizontal, I'm going to go ahead and just pick vertical for right now, but you can pick it in horizontal. You just need to make sure, like I didn't do just a second ago, that you rewrite it so that it's in the same format. Because notice how we have our imaginary number and then our real number. So if I were to rewrite this, I would put the real number in front plus 2i, and we are adding these together. So this is 6i plus 2i, which just gives us 8i. And then -9 minus 4 is going to give us -13. The reason why I rewrote it that way is because this is in the complex number correct way of writing that. The real number goes in front, then the imaginary number comes second. All right, so that's it for adding. Now let's go ahead and talk about subtracting. Please pause this video at any time if I'm going too fast. Okay, whoever's in the room, please make sure you're able to pause the video for the students if you can. If you're watching this on your own, you do you. You pause it when you need to. So we're going to subtract with a vertical format. Okay, so this does matter which order you're going from, because if I say subtract 5 from 15, this is the number you start with because it's saying 5 from that number. All right, so when we are subtracting, you do need to make sure that you are going to subtract the 3x cubed plus 2x squared minus x plus 7. Be careful with this. Remember that you're subtracting all of these terms. So when you do that, it's actually going to end up being 8x cubed minus 3x cubed. So we're going to end up with a 5x cubed. This is negative 1 minus 2x, so that's going to end up being negative 3x squared. Next one, we have negative 5 minus a negative becomes positive, so we're really just adding 1. So that's minus 4x. 1 minus 7, which becomes negative 6. Okay, and that is going to be our solution. Now another thing that you could do is you can go ahead and distribute that negative to every term, and that way you end up adding the two together. So that would just be 8x cubed minus x squared minus 5x plus 1. This is going to stay the same, but I'm going to distribute that negative. It's up to you. If you're struggling with the subtracting and from remembering to subtract each term, just distribute, and that way you can add them together. Okay, so now you're just adding these terms together. Your choice. Okay, we're going to do a horizontal format. Remember, you're subtracting this from that. So if we start off, we're going to end up with 4z squared plus 9z minus 12. You're subtracting everything. So we've done this before in this format. Personally, I favor this format because I can see it clearly. You're going to distribute that negative to all the terms on the outside, so you'd really have 4z squared plus 9z minus 12 minus 5z squared plus z minus 3. So now we're going to go ahead and combine all of the like terms. 4 minus 5 gives us negative z squared, and then 9 plus 1z gives us 10z. Negative 12 plus 3 is going to give us negative 15, and that's going to be our final polynomial, and that's just subtracting. Now they give us the choice to go ahead and use any format that we'd like for subtracting these complex numbers. So when we're looking at 3 minus 5i from 7 plus 4i, we can go ahead and use either format. I'm going to go ahead, I prefer the horizontal format. It's your choice. So that's the first one, minus 3 minus 5i. Distribute the negative, so this becomes negative, positive. I now am adding those two together. So 7 minus 3 is going to give us 4 plus 9i. So that's it for adding and subtracting. Now we're going to go ahead and move on to multiplying. Okay, so when we multiply, we do need to double check to make sure everything's been combined, and we'll go ahead and do that real quick. Now this first one we're going to do vertically, which is something we typically don't do. Just remember how you would have multiplied like 53 times, well, I'm going to start off with a larger number, 521 times, and And I said 53 a second ago, but 43. I'm crazy. And remember, you do need a 0 as a placeholder. It's just we're going to talk about that as being kind of old school multiplying vertically. And you can do this on that. All right. So when I multiply these two polynomials together, I'm going to go ahead and set it up by leaving the larger polynomial on top. So this is going to be y minus 2, and I'm going to multiply these terms together. Remember, we always multiply by the back terms. Negative 6 times negative 2 is going to give me positive 12. Negative 2 times positive 3y, which would just give me negative 6y. Negative 2 times 2y squared, that's going to give me negative 4y squared. Remember, we're going to go to the second term, so we do need that placeholder because I am now in kind of like the tens place where you would normally be. So we need to add that 0 as a placeholder. Negative y times negative 6 is going to give us positive 6y. Negative y times 3y, which is going to be negative 3y squared. And negative y times positive 2y, which is going to give us negative 2y cubed. All right, now what we're going to do is we're going to go ahead and combine like terms. So we have 12. This becomes 0. And then, or cancels out. I don't even need the 0 because this is going to be my final answer right here. Okay, negative 4y minus 3y is going to give us a negative 7y squared. And then we're going to go ahead and just bring down the negative 2y cubed. And this is our final answer. Personally, I don't really like vertical format. It's up to you if you see that, if you like how this is used or you like how this is formatted, go for it. Personally, I like the horizontal format. Whoops, not that one. So that means that we're going to take x plus 3 times 3x squared minus 2x plus 4. Now remember, if you didn't have enough time on that last problem, please go back and see our review and pause. Because it's a trinomial times a binomial, you have two options. One, you can distribute it. Now normally we distribute it with a binomial times a binomial, and we use FOIL. You can't really use FOIL on this one because you need more than just first, outer, inner, last. What you would do, you would end up distributing the x to all of the terms in the second polynomial. So I'm going to distribute that x to all three terms. So this is going to end up being 3x cubed minus 2x squared plus 4x. So that's going to be the first part. I'm going to change colors for the second one. So the second part is we need to distribute the 3. So that 3 is going to be distributed by everything on the other polynomial. So this is going to become 9x cubed minus 6x plus 12. And then we're just left to go ahead and combine like terms, which would end up being 3x cubed negative 2 plus 9, which would just end up being positive 7x squared, 4x minus 6x, which is minus 2x, and then plus 12. So that's our in polynomial, and you're all set to go. One more thing that you could do with this if you liked the area model, and this is totally up to you. Okay, you kind of use this as a Punnett square in biology last year when you were doing gene creation. I don't know what you would call that, sorry. But this would be x and 3 on one side of your Punnett square or area model, because you would multiply these together. So that would be 3x cubed minus 2x squared, 4x, because you're multiplying the horizontal and the vertical columns and rows. So this is going to be 9x squared minus 6x and 12, and then you would combine like terms. You would end up with 3x to the third 9 minus 2 would give you 7. 6, negative 6 plus 4 gives you negative 2x, and then plus 12. So both ways will work for you, whatever works best for you. But if it's asking for horizontal format specifically, that would be this. Okay, so let's go ahead and multiply some complex numbers, and you can multiply them either way. I'm going to multiply them using FOIL, because look, we've got a binomial times a binomial. Okay, so first, outer, inner, last. All right, so we need to combine like terms, this would be 15. Okay, 40 minus 6 is going to end up giving me 34. And then our last one, we can simplify this a little bit more, because remember when we talked about I being a square root of negative 1? We don't want to simplify that, but we could, if it's I squared, that would just be the square root of 1 squared, which is just negative 1. So that we can multiply out. So 15 plus, this would become positive 16 when you multiply it. Well, I want to go ahead and go to the next line on that. And those are common terms, like terms, so we're going to combine like terms. Remember, your real number goes first, so that's 15 plus 16, which would just give us 31, plus 34i. All right. And that does it for, nope, we've got one more multiplication problem, I lied. Here we go. So looking at this multiplication problem, I noticed that I have 3 binomials, but we've never multiplied 3 binomials at the exact same time. But I do know if I only had 2, I can multiply that out and then multiply it by the third. So let's go ahead and do that. I'm going to focus on x minus 5 and multiply it with x plus 1 first, and that's going to end up giving us first, outer, inner, last. But don't forget to bring this one down. We're just not going to multiply it right now. I'm going to wait. It's probably going to need more space. X times x gives us x squared, and then plus x minus 5, x minus 5. Okay, this becomes negative 4, x minus 5. All right, now that I've simplified that first polynomial, which is now quadratic, I need to go ahead and multiply it by my x plus 3. So I'm actually going to distribute all the x values first. So that's going to be x to the third minus 4x squared minus 5x. And then we're going to distribute that 3 as well. So it's going to end up being plus 3x squared minus 12x minus 15. And now I'm left to go ahead and combine like terms. I have only one cubic. Yes. So that'd be x to the third. And then I'm going to look at all of my squareds, which is negative 4 plus 3, which is going to be minus x squared minus 1. Next is the x to the first power, so that's going to end up being minus 17x plus 15. And there's my polynomial after I've multiplied those 3 binomials together. Okay, it's a cubic fourth term polynomial. Nope, cubic polynomial. But there are 4 terms. All right, I hope you have a wonderful day. If you need help, please go see Miss Young. She's offering her help and she's available. Check the tutoring time schedule. Remember, that's also posted in the Google Classroom. She's got her link posted on the tutoring page. Have a wonderful day. I hope you guys are asking the questions that you need to ask and working together to get this work done. Or not just the work done, but the understanding of this content. Thank you. Have a good day.